Same thing, but this time it's the same question, right? But I divided out the ratio. So instead of giving you here, so in this question here, I gave you the diagram of where the ratio would be, and we got the ratio, right? So we got from the diagram, I got the ratio. From the diagram, you got the ratio, all good. I took the ratio away, I took the diagram away, and I just found the ratio. But here, I made it into a decimal. Here a decimal, and here I left it with the ratio, right? So I can ask it in any form. I can ask it as a fraction, right, where I already did the point and I got the fraction for you, or I can divide it and give you a decimal. It's the same question all around. So here, I'm asking you, determine the measure of the two angles associated with each of the following to the nearest degree between 0 and 360. What does that mean by two angles? That means, and I'm just going to draw a little... Okay. No, 1 second. Okay. So what does it mean by two angles? The other question that we did was more... Are you okay to wait? Okay. The other question that we did, so look how it's different, right? So the other question was more specific. We could picture it. So compare. This one, we knew exactly where the coordinate was, right? Exactly where the coordinate was. We knew exactly. It was in quadrant 4. 1, 2, 3, 4, for sure, because I gave you the coordinate. I gave you the point, right? So then you knew. Then we knew how to draw it. We'd get the missing angles and stuff like that, missing sides, all that stuff. Here, I didn't tell you which quadrant it's in, but I did tell you that cos is negative. So I know that the ratio between, what's cos again? SOHCAHTOA? Adjacent to hypotenuse has to be negative. If I know it's negative, then I know that the adjacent should be negative to the hypotenuse. So you see all the processing you're doing? They already processed this for you. If I'm not telling you specifically which quadrant it's in, they already figured out this whole ratio thing. How did they figure it out? CAST. That's the thing that's processing that the adjacent to the hypotenuse has to be a negative ratio. And because I didn't specifically tell you what the point was, you have to say, well, then there's two answers. Because cos is negative, has a negative ratio in two of these quadrants. There's always two. Two where it's positive and two where it's negative. Which two will cos have a negative ratio in? Cos will have a negative ratio in. A is all of them are positive. S is sine is positive, so it's going to be here. And T is where tan is positive. Will cos be positive? No, so cos will be negative here. Okay, but here's where cos is positive. So one more time. Cos is negative. The ratio of adjacent to hypotenuse is negative. They just turned it to a decimal, right? So it could have been a fraction, but they turned it to a decimal. So it's a negative. A means all of them are positive. C means C is positive, cos is positive. So I chose the S and the T to draw my two arms because I didn't tell you specifically where the terminal arm was. So the question we did on the other page, I told you specifically it was in quadrant 4. Here you have to give two answers. I gave you the hint. What are the two angles? I won't give that all the time. Usually maybe in grade 11, by grade 12, I'm not telling you. On their test, I didn't tell them, and they had to find two. And they had to know. And some students were like, you want both? And I'm like, what do you think? Of course I want both. If there are two answers, give me both. Okay? So here, this year, we probably will tell you, we might not. So you should know. Every time I'm doing a cast rule, there's two positive and two negative for every ratio. So think about this one. So let's set up the next one. I'm going to calculate this. We're not done, but let's just set up the next one just for a second. Okay, so what do I mean? One more time. And you can write cast as many times as you want. C-A-S-T. You can write it in every single one. Some people don't write it on every one, and some people do. Cast rule, so C-A-S-T. Yeah.
You need to draw that.
Again, right, I'm going to ask you to draw it this year. Okay, just this year. Next year, up to you. Just for this year, just so I can see that you got the two quadrants and stuff, okay? Okay, I'm pretty sure. So my answer right now is yes, I want you to draw it. If I change my mind, I'll let you know. But yeah, grade 11, I want to see. Yeah. Okay, grade 12, no, you absolutely don't. Okay, you do not have to at all. Grade 11, I want to see the quadrants. That way I know your process. So yes, my answer is yes. Okay, unless told otherwise. So here, sine is a negative ratio, right? They already did the O and the H, they divided it, right? So sometimes they divide it, look, sometimes they leave it in fraction form. Same question. My ratio is negative. If sine is negative, which two arms am I going to draw? Am I going to draw it here? No, all of them are positive. Am I going to draw it here? No, sine is positive. Am I going to draw it here? Yes, I'm going to draw it here because tan is positive, which means sine is negative. And then here, am I going to draw it here? Yes, because cos is positive, which means sine is negative. So every single time you do this, there will always be two answers. Two for the positive, two for the negative. So that's why, from now until forever, when I ask you from 0 to 360, look, it's 0 to 360, which means it's one cycle. We will do different cycles later. Sometimes we'll do 3 cycles, like go around and around and around, and then backwards, all that sort of stuff. But for now, we usually kind of keep it steady for grade 11 because we're just introducing you. So 0 to 360, that's our gift to you, right? And we might change it, but this means one cycle, just easy. That means there's 2 answers for every. So look, here and here, 2 answers for every answer. So every time I ask you this, there'll be 2 answers for a positive, 2 answers for a negative. So what does that mean, 2 answers? I still don't know the angle. Determine the measure of the angle. So I need, my first step will always be to find B. So I want find RAA, which is my beta. I usually use beta to represent RAA first. That will always be my first step. So I want to find my RAA first. Okay, so do that first and then fix my answer. Okay, and again, if you do it differently, that's fine. Show me how you want to do your answer so I can check it before an evaluation to see that you're showing me enough steps. And again, grade 12, you don't have to. You can go straight to, if you're faster at it, you can find the RAA faster and you're doing it all in your head, that's fine. Okay, but for this year, I want to see the RAA. Okay, so related acute angle. So what do I do to find the related acute angle? I switch this to cos beta equals 0.627. Does that make sense? So I'm going to switch it. Beta means it's positive. Right? I switch this to beta, and I switch this to a positive ratio. Switch it to positive. Then I'm going to go beta equals, and then on your calculator, make sure you're in degrees. I'm going to do shift cos 0.627. What do I want? Nearest degree? Oh, please, please, please read the question, such wasted marks. Okay, nearest degree. Always read it. And I did that equals. And I'm getting 51 degrees. Is that okay? 51, so approximately 51 degrees. Only round once, don't round twice. 51 degrees. Yes?
Do you need that first step? Or can you go straight into
Beta equals inverse? Or just beta?
no, beta equals inverse?
Yes, yep. So here you could put instead beta equals, so you could do beta equals inverse cos. Yeah, same thing. Yeah, either one. Yeah, so that one, yeah, or. So I'll put or. Yeah, yep, either way. You're showing me what beta is. So beta is the inverse. There you got 51. Good. That is your dot. That's your dot. Yep.
So every time it's negative, do you want us to flip it to positive?
Yes, that gives you your related acute angle, which is your dot. Right? You can put the beta there. I found that when I wrote it there, it was too messy. I couldn't read my own writing, so I just put dots. My dot is my beta. Okay? So I put my dot, which is also here. And remember, every time we draw this, the dot, the related acute angle, is between the terminal arm and the x-axis. My x-axis is the only one that's important. It's always between the arm and the x-axis. Okay? So now fix it. Okay? Fix this answer. So every time I get it, it's related acute angle, which is only the dot. So that means that we're going to do this. So that is one answer. Okay, so I'm going to go theta 1 equals, so this will be my theta 1. I'll do it in different. Theta 1 is going to be 180 minus 51. Does that make sense? Minus 51, which will get me 129, 129 degrees. So that, does that make sense? It's 129.
So beta's the little...
Beta's always that one, yeah.
And theta's question.
And theta is the actual answer, yeah. Okay, next one. Ready? I want to go to that arm. Starting from the positive x-axis, I want to go to this arm. So flip it all the way around. We're going to go like this. Whoosh to here. That'll be my theta 2. You don't have to label the angles on the graph. I just want to see the arms, right, and which quadrants you're in. But this is for your notes, so theta 2. How would I get that, the full angle, all the way to this arm? 180 plus 51, which equals 231. Does that make sense? So we get 2 answers. So I'm going to get 2 answers, theta 1 and theta 2. So those are my 2 answers. If you want to, you can check it if you do cos of these 2 angles. But the unfortunate thing is because we rounded 129, it's negative 0.629. Do you see it's a little bit off because we rounded? And if I do cos of 231, see how it's rounded a little bit? It's negative 0.629, right? It should get me back the ratio, right? You can check it. It's just that the checking is kind of rounded off. So those are my 2 answers. Those are my 2 answers, 129 and 231. Now, let's try it again. We're going to get these 2 in this little bubble over here. So let me do the ants. Let's do this full one here, and then I'll do a little kind of a bubble to summarize here. So first thing I'm going to do is I'm going to find the acute angle. So I'm going to rewrite the question. I rewrite the question, and I go sine beta equals 0.819. Beta equals, and yes, you could write either one of these 2 steps, so you don't have to show both. Right, that's what you were asking? Yep, you could show either one of these steps, and then you're going to get approximately, and I got 55 degrees.
And that's for the
That is always this dot. Always close to x, always close to x. My x is the only one that's important. It's between the terminal arm and the x-axis, never any other direction. Always between the terminal arm and the x-axis. Remember I said you're making like a bow tie. It only goes towards the x-axis that way, never the other way.
So where's your theta?
Okay, yeah, and your theta is always from, my first one will be from my starting arm, which is the positive x-axis, heading around here. Right, so we know it's more than 180. So that would be my theta 1. So theta 1 would get 180 plus 55. Does that make sense? Right, and I'll summarize this in another second. Okay, equals 235, 235, yes, not wrong. Okay, then my theta 2, ready? From the positive, whoosh all the way around here. So my theta 2 is going to be, how do I get this whole thing minus that slice? What'd you do?
360.
Yeah, 360 minus the 55, which would get me 305. That's it. We get my 2 answers. 2 beautiful answers. Okay? So just to summarize, I'm going to do a little bubble here. When we're finding these angles, I should have left a little bit of room. I didn't leave room. I'm just going to do a little bubble here. Okay. When I'm finding the angle here, it is just whatever the beta is. That one's okay, right? When I'm finding the angle here, this is going to be 180 minus that question mark, right? Does that make sense? Minus beta, also minus beta. If I do the arm here, this will be 180 plus beta. Does that make sense? And if the arm is here, and that's the dot, this would be how much? 360 minus beta. Does that make sense? So whenever the arm's here, it's 180 minus the beta, If the arm stops here, it's 180 plus the beta. If the arm stops here, it's 360 minus the beta. And this is just beta, right? That would just be beta. Does that make sense how I got those? Is that too small? Sorry. Here, zoom in. Right, so it's 180. Here, I'll zoom in again. Better? So this is, if the arm stops here, it's 180 minus the little beta, 180 minus beta. If the arm stops here, it's 180 plus the beta, right? And if the arm stops here, it's 360 minus the beta. Sorry, what was the question? It's okay.
I just thought it was for the tan question.
No, just in general. So just my thought bubble, right? Just remembering. So that's how I got all these quadrants. Does that make sense how we got these? So for this one, it was 180 minus it because it's a little less. Here it's 180 plus, and here is 360 minus. Okay, so I'm getting that's how I get my 4 quadrants. Does that make sense? Do you want me to redraw that, or is that okay? Okay, all right. Back out. Okay, so then let's do tan. Are we getting used to it now? So then the first step I do is I get my beta. So I'm still going to do tan beta is 12.3. And again, you don't have to show both of these steps.
Why don't you make negative 12?
No, I always want positive. Beta is always positive.
Oh, so you don't do anything.
Don't do the opposite. It's no, yeah. So we want to keep this one, so we always keep the opposite. It already is positive,
You don't
but
change anything else.
no, you always just want to keep it positive so we can get the dot, right? So then I get from this one, I got 85. Correct me if I'm wrong. I got approximately 85 degrees, right? And make sure you try to do degree symbol, please. Right? A lot of people just leave it off the whole thing and then they forget it everywhere. So just try to keep your degrees everywhere. Okay? So that's my dot, but I want to be in which quadrants? So wait, sorry. C, A, S, T. So which 2 quadrants do I want to be in? The tan is positive quadrant, so it would be A for all positive, and the T, yeah, that's it. Right? So we got the pattern. So if tan ratio is positive, if the OA, opposite to adjacent, is positive, that means it was here with the dot there, or here with the dot there. So if the dot is in the first quadrant, then it is whatever it is. So then theta 1 is just 85. Done. Because it's in the first quadrant. Is that okay? So that's my first one. Easy. That's always nice when it's positive. So theta 2 equals, so really, if I give you a positive, you should get 1 mark. That should not be wrong. Right, I'm going to zoom out a little. There you go. So then theta 2 is going to be, watch, we're going all the way around from the positive x-axis. Are we getting used to drawing it from the positive x-axis around? So how do I get this one? It would be 180 plus the 85. Is that okay? So plus a bit more. So that'll be 265. Done. See how much faster it is? Okay, so last one. I'm going to pause this.